Okay, guys, so I'm going to do two word problems. And so here is the first one, and we're going to follow the same setup for so I've got a changing picture, I've got a picture at a moment, at the certain moment that they're asking us about, and then what do we know, what do we want, and when, at what moment do we want it? Okay, so the radius of a cylinder is increasing at a constant rate of 7 inches per second. Okay, so the cylinder is increasing at a constant rate of 7 inches per second. And the volume is increasing at a rate of 1,474 cubic inches per second. Okay, so we can actually put these right away in what we know. So we know that dr, maybe I should read it first, but okay, I'll write this. So dr dt, it's increasing, so positive 7. dv dt, also increasing, so that's a positive rate. Okay, at the instant when the height of the cylinder is 9 inches, okay, at the instant when the height of the cylinder is 9 inches and the volume is 457 cubic inches, what is the rate of change of the height? Okay, so what is the rate of change of the height? So we want dH dt when the height itself is 9 and the volume itself is 457. Okay, now the changing picture, you only label it with non-constant variables. So that's the radius, this is the height, okay? And now our picture at this very moment, the height is 9, and then I'll just write down here that the volume is 457. If the volume was always 457, then maybe you could put it over here on the changing picture because it's a constant. And you could label the changing picture with things that are constant if you want. But we would never want to label a changing picture with 9 because the height is only 9 at a certain moment. Okay, so now they're giving you, so the volume of a cylinder can be found with this equation. So I'm going to write down the equation, and then I'm going to take its derivative. All right, we're going to need product rule. So think of this, pi as a constant. So I'm going to think of this as one, as the first function, this is the second. And remember, t is the input variable, so it's prime after v, r, and h. So v prime. 2 pi r, but you need an r prime after, and then you bring down the h, plus, bring down the pi r squared, derivative of h is 1, but we need an h prime. Okay, so we want h prime. So I'm going to leave a placeholder for everything except 2 pi h prime, okay? So that I want to be able to plug in a number for everything else except for h prime, and then I can solve for it. So v prime, they gave us, okay, 1474. R, we don't have, they did not give it to us, so we're going to have to do some problem solving here to find it. R prime, we have, okay, it's 7. H, at this moment, it's 9. R, again, we need to find it. Okay, so now you can go back up here. So if we know the volume is 457, we know the height is 9, we can find the radius because we can plug both of these things in to the volume formula. Okay, so, yes, so over here, actually, let me do an aside. Aside, because I just want the notes to be organized. Aside to find R. Okay, so V equals pi r squared h. So in for volume, we can put 457 pi r squared, and then in for h we can put 9. Okay, so we have 9 pi r squared is 457. So we've got r squared is 457 over 9 pi. And we've got r is radical 457 over 9 pi. Okay. So this is going in where the r's were. So 457 over 9 pi. 457 over 9 pi. Whoopsie, no, that's the square root. Sorry, that's what r is the square root. Okay, so now I just need to get h by itself. So, yeah, so we've got, all right, in a square root squared, you just get like the thing that's under it. So, this is pi times 457 over 9 pi. I squared it, so the square root went away. H prime equals 1474. And then 2 times 7 times 9 is 126. So minus 126 pi radical 457 over 9 pi. Okay. Now, as I have said before, you need to understand every single detail. Okay, so if any of that is not clear to you, make sure you figure it out. Okay, now, I'm going to type this into my calculator, and I'm going to divide it by what's in front of the h prime. Okay, so if you go, how does it go? Alpha y equals, okay, and then you can get this fraction thing. All right, so 1474 minus 126 pi radical, what did I do? Radical alpha y equals 457 over 9 pi all over. Now guys, if you notice these pi's are going to cancel, okay? You could plug them in, but I'm not even going to plug them in because I noticed that they cancel. So this is just 457 over 9. Okay, so h prime equals negative 2312, and then inches per second. Okay, now I am going to do another one. Okay, so there's one. So here is another one. Now, if that was a lot for your brain, maybe just pause the video, try to digest it, maybe write down like the time, and then come back to this second one. But this time, we've got the height of a cone is decreasing at a constant rate of 8 inches per minute. Okay, so decreasing at a constant rate of 8 inches per minute. That's the height. So we know dh dt is negative 8. The volume remains constant. So volume remains constant, a constant 247 cubic inches. So V equals 247. And then guys, I'm going to write the word constant there because the derivative of a constant is 0. All right, so if they're telling you that a certain dimension or volume or something or area is always the same, it's not just this at a certain moment, it's always the same. You should write constant there to remind yourself that when you do take the derivative of V, that's going to end up being 0. Okay, the volume remains a constant, this. At the instant when the radius of the cone is 9 inches, the instant when the radius of the cone is 9 inches, what is the rate of change of the radius? So we want dr dt when the radius is 9. Okay, now my changing picture, and guys, you might be wondering, like, why are we labeling the changing picture? Tomorrow's video, we're gonna need to use the changing picture a lot. Okay, so you wanna be in the habit of labeling a changing picture with just variables. Okay, so now at this certain moment, we've got a radius of 9, and we know that the volume is 247 constant, not at a moment, it's constant. Okay, the volume of the cone can be found with this equation, all right? And then, so now I got to write down this equation. 1/3 pi r squared h. Okay, and look at that is the first function, that is the second. 1/3 pi, that is just a coefficient. So v prime equals 2/3 pi r prime h. Remember, you need to understand every single detail. So if that doesn't make sense, please think about it. All right, then I'm just bringing this down. Derivative of h is h prime. Okay, so I want r prime. So I'm going to leave a blank for everything except for r prime. So v prime r prime h pi. Okay, now what can I start plugging in? Guys, v prime. V is constant. The volume is always 247. What's the derivative of 247? It's 0. What can go in for r? R, they're telling us, is 9 at this moment. Oh, here's another where r goes. So 9 is going in those spots. What can go in for h? I don't know. I have to figure that out. What can go in for h prime? -8. Okay, that's something that, we knew. All right, now I got to do an aside and solve for h using this information at this very moment. Okay, so aside to find h. All right, so you know volume is 1/3 pi r squared h. The volume in this case, sorry, I'm like writing to the side. Okay, the volume is 247 constant. 1/3 pi, 9 squared is 81 h. So 1/3 of 81 is 27. So that's 27 pi h to 47. H is 247 over 27. Oh my gosh. Okay, 27 pi. So 247 over 27 pi. 247 over 27 pi is going in where that h was. Now I'm going to do the same thing. Well, I'm going to do this. I'm going to subtract this over to this side, and then I'm going to divide by like the rest of that. So, all right, so actually, yeah, let me just write it like this. Well, 2/3 of 9 is 6. All right, so this is actually 6 pi 247 over 27 pi. The pi's cancel, so you can cancel them if you want. R prime equals. Now I am subtracting this over, but guys, if you notice, this is gonna be like a negative number anyway. Because like this was, if you just do the regular numbers and not the pi, it was that's 1/3 times 81 times -8. So this is really negative 216 pi. So we'd be adding it to the other side. So I'm going to go 2, so it'll be positive 216 pi. Remember, you got to understand every detail. Okay, and now I'm just going to divide. So this is 216, actually, You can't really see well. All right, so alpha y equals, shoot. All right, 2/16 pi over 6 pi, parentheses, alpha y equals 247 over 27 pi. Okay, there it is, 12.363. 12.363 inches per minute. Okay.